Hi, my name is Amir Nota, Product Development Engineer here at Beyond LED Technology. I want to welcome you to be part of my family. Today I will go over the LED basics with you. If you understand this chart right here, this is your kind of 70% of your training. First, I start with the difference between wattage and voltage. So the wattage is the power consumption. So higher the wattage, higher the consumption, and your power bill is more, right? Lower the voltage, lower the wattage, your power bill is less, right? The voltage is your current. So input voltage in North America, we use 110 to 120 volt. In Europe and Asia, we use 220 to 240 volt. So if you give a wrong power, like a wrong current to a product, wrong means anything excessive voltage, anything more. So if you give a wrong voltage, so let's see if an American product, North American product, which made for input voltage of 110 to 120 volt, if you take this product to Europe and you give a wrong power, right, the product immediately explode or fail, right? But if you bring the European product or Asian product here in America, which the input voltage is 220 volt, and you give 110, it will not work. It will not fail, right? So if you give a wrong voltage, an excessive voltage, then what happens? That your product will fail. So input voltage is really important. In North America, your residential to light industrial is all about 110 to 120 volt. Offices and commercial to industrial, a lot of places are 277 volt, right? So input voltage is 277 volt for light industrial and commercial places. Residential to normal offices, buildings, all are 110 in North America. Now the wattage and lumens go hands on hands, right? Of course, the more power, the more brighter is the light, right? But now, if you look at it, 150 watt is giving 21,000 lumens. The lumens is the brightness, how bright the light is. So lumens measures, the brightness is measured in lumens. So 150 watt, 21,000. Approximately you're looking at it 130 lumens per watt. The average light in 2020 approximately average about 135 to 140 lumens per watt. Now if I go back 5 years ago, right, it used to be 70 to 80 lumens per watt average light efficiency, right? So example, 100 watt light 5 years ago used to deliver only 7,000 lumens. Nowadays, 100 watt light can deliver up to 14,000 lumens, or even in some cases higher lumen efficiency. So the wattage and lumens go hands on hands. Of course, the higher the wattage, the more brighter is the light. But if your customer call you and ask you, okay, how much is your 100 watt light? The first question to be asked about the lumens. Maybe the other competition has an older technology light which the efficiency is only probably 100 lumens per watt, right? So the right question asked is, Mr. Customer, are you looking for, how many lumens are you looking for? Right? What's the application of the product? Not just by the wattage. Because wattage efficiency can be 80 lumen per watt, 100 lumen per watt, 120 lumen per watt. Even in our own product line, we have the product which go as high 180 lumen per watt. So the brightness is the more important part versus the wattage of the light. Now, you know about the wattage, you know about the lumens, you know about the input voltage. The next part is about the certifications. Here, there are 4 types of certifications in North America: UL, DLC, ETL, Energy Star. UL and ETL certifications are only safety certifications, has nothing to do with the quality certification. DLC and Energy Star are quality certifications. Most of the commercial products fall under the DLC category. Some product like downlights, residential bulbs, those falls under Energy Star category. Now DLC and Energy Star go parallel. Means a product which falls under the DLC cannot be Energy Star listed, and the product which falls under the Energy Star category cannot be DLC. Why the UL, DLC or ETL, Energy Star is important? So UL basically is a safety certification, right? So it's required to install in North America. Any lighting which from the commercial and residential product has to be either ETL or UL certified. And DLC and Energy Star is required to get the rebate from the power company. Now, in order to get the certification, what's the process of getting the certifications and what other certifications are available in lighting industry? Now, before we talk about more on the UL and DLC side, let me tell you some more certification is required in order to pass the DLC certification. Now let me tell you what is the qualification process to get the DLC certification, right? To get the DLC certification, we have to provide a testing report to the DLC company, right? So what are the certifications? Today I want to discuss about how the DLC process works. What kind of reports we have to provide to DLC in order to be a product to be qualified for DLC. The first report is LM79 report. Now what is LM79 report? The LM79 report is a testing report for the entire product. What does it mean by entire product? Means, just an example of a car. You buy a Honda Accord, right? So when the Honda Accord is ready, the testing report for the product of a full ready-made product. Now, there's another report is called LM80 report. The LM80 report is only for the LED, for the chips. LED we also call chip. So LM80 report is for the product only. I'm talking about unfinished product, for the chip only. Now LM79 report for the entire product when the product is ready. LM80 report for the chip. So just an example of an Honda Accord, right? If you look at the Honda Accord specification, it says that this Honda Accord can go up to 140 miles per hour, right? Now, if you look at the specifications of a tire, which is a Michelin tire, which is already built into Honda Accord. Now, Michelin tire shows that this particular model has an efficiency can go up to 240 miles per hour. Now, Honda specification shows that Honda Accord what can go up to only 140 miles per hour? Yes, because there are a lot of components are controlling the tire, the engine, the transmission, the body, which is basically stopping a tire not to go to its maximum capacity, right? So in LED, same thing, right? If LM80 report shows that this chip lumen efficiency is 200 lumen per watt, and if you look at the same chip which is built in to a particular product, and the specification sheet shows that this particular light which has this 200 lumen per watt efficiency chip can only deliver up to 135 lumen per watt, means is the other component, the driver, the other component stopping the chip to a certain limit, efficiency lumen limit, that this particular chip can only deliver up to 135 lumen per watt. But if you look at the chip efficiency, can go up to 200 lumens per watt. Now, LM79 report is for the entire product. LM80 report is for the chip. Now, let me go over with you in IES files, a photometric report. What is IES file and what is photometric report? IES file is required in order to design a project. Example, if a customer asks you that he needs the lighting for his brand new warehouse, which is 100,000 square feet warehouse, and there is no existing lighting. Now, how will be able to determine that how many lighting fixture it requires to light up the entire 100,000 square feet warehouse? Now, IES file, what it does, that there's a different type of software. The one software that we use is called Dilux. We insert a file, the IES report, to a Dilux report along with the blueprint of a warehouse, right? And it generates a photometric report which basically determines that how many lights you need to light up this entire 100,000 square feet of warehouse. So there will be no surprises. There is no way a person can determine how many lights it requires to light up the 100,000 square feet of warehouse without a software, Dilux software, IES file, and a blueprint to determine how many lighting fixtures you need to make the entire warehouse lit up. Now let me recap. We started with wattage. We started with voltage, the difference between wattage, voltage, the lumen efficiency from 70 lumen per watt about 5 years ago to 170, 180 lumen per watt now. We talk about the UL certification, which is safety certification. We talk about a DLC certification, which is required to get the rebates from lot of power company. Now, we also talk about LM79 report, which is the testing report for the entire product. We talk about LM80 report, which is for the chip only. And we also talk about the IES file, which is required to generate a photometric report for the project. Now, let's talk about CCT, which is the color temperature of the product. If you look at this chart right here, the CCT is measured in kelvins, color temperature, which measures in kelvins. So if you look at it here, the 2000 kelvins is kind of a reddish, orangish color. Now, once it turns to 3000 K, it's more softer and it's more kind of, we call it warm light. If you go into the 4500 K, it's daylight, but still little bit of warmish daylight color. Now, if you go up to here in the middle, a 5000 color temperature, right up here, 5000 color temperature, which is a pure daylight color of a light. There are colors available up to 6000K, 6500K, 7000 color temperature. But as the numbers, as the kelvins go up, your light is keep getting softer and softer, and now at certain level it will deliver kind of a bluish type of light. It's no longer white anymore. As we talk about the DLC Energy Star, there are a lot of technical requirement in order to be qualified for DLC. Of course, we have to provide LM79 report, LM80 report, IES file to DLC in order to get the certifications of DLC. Now, what are the requirements? Few requirements which you must know. In order to be qualified for a DLC and Energy Star, indoor lighting, the product has to be 5000K or less than 5000K. So if your color temperature of the light, if a color temperature of a light is 4000, 3000, 2700K, it's no problem. If anything higher than 5000K in the indoor lighting category cannot be DLC or Energy Star. The maximum color temperature of a light to be qualified for a DLC under the indoor lighting category has to be 5000K or lower. Outdoor lighting requirement, the product cannot be higher than 5700 Kelvin. So 5700 Kelvin or lower can be DLC or Energy Star. When a customer sees that this product is qualified for either DLC or Energy Star, it automatically comes with the 5 years warranty. The manufacturer has to provide 5 years warranty on most DLC and Energy Star qualified LED lighting products. The next thing is about IP rating of the product. IP is a code letter, the first digit and the second digit, very important. Usually, most of our lighting, outdoor lighting, the IP rating start with IP 65, 66, 67 or IP 68. So the first digit, 6, means it's dust tight, right? And the second digit, if the product is IP 65 rated, means 6 is dust tight and the other 5 is protect against the jetting water. The street light, wall packs, for the outdoor rating product has to be minimum IP65 rating. Now there are products, if you look at the IP66, again the 6 is dust tight, the second 6 is protected against powerfully jetting water. IP67 dust tight and 7 is protected against temporary immersion in water. So it goes inside, the product can go inside the water. And IP68 protected against continuous immersion in water. So IP rating, there are tube lights, there are LED tubes rated IP44, IP54. If you look at this chart, IP54, so 5 is protected from amount of dust and 4 is protected against splashing water. So if you understand this chart, basically the most IP rating that we use, IP65, IP66 and IP67, IP68. Some indoor lighting we use IP54, IP44 like this. I've never seen using anything IP11, IP22, IP33, but in the lighting industry, in our product line, most products are outdoor rated product IP65, 66, 67, 68, and some indoor lightings from IP44 to IP54 and stuff like that. Basically, it's your waterproofing, dustproofing level of the product. The last thing I really want to discuss is before I hand over to MJ Noorani, who's going to go over the product application, is very important part about the input voltage of the product, right? As we discussed earlier, that input voltage, standard input voltage in North American market is 110 to 120 volt. Now, how about a product is a low voltage? Just an example, your smartphone, your tablet. So if you look at your smartphone chargers, so this is my laptop charger. If I'm reading the specifications here, you get input voltage here to 110. You can directly plug in. But what it does, the big piece here, what it does, it changes your 110 to 5 volt, which is required for a laptop. So laptop only requires 5 volt. Now what happened, just an example, I cut this piece out and open those wire, buy a regular plug from dollar store, plug in directly and plug this to a laptop which requires 5 volt. What will happen? The laptop will immediately in microsecond will explode or fail or burn. The reason is this, because input voltage of a laptop is 5 volt and I'm bypassing this driver, we call it driver, LED driver, I'm bypassing it, a converter, and give a direct power to a laptop which is 110. Remember, anything excessive, anything if you give more can be harmful. Anything if you give less, maybe no effect, or maybe this thing may not work. There is no, you are giving less power. You must understand the input voltage of a light is very, very important. The most LED chips are low voltage, right? But the specification sheet shows input voltage is 110, 220 or 277. What does it mean? Same thing as a laptop, right? The laptop 5 volt, it says 110, means there is a driver, there is a converter in between which converting a power to whatever the required power is required for the particular product or LED, right? So most LED chips are low voltage, but there is a driver in between which converts the input voltage to its requirement, right? So I hope it's, you guys understand this voltage and wattage is really a key to understand the products of LED lighting. Thank you so much. I'll hand over to MJ Noorani. He'll go over the product details. Thank you so much.